Welcome back. This video is kind of a second part of our Chapter 8 problem solving work. Today, I'll introduce to you the concepts of what's called a decision analysis. And there's lots of different kinds of decision analyses. This one is typical, and I'll go through the details with you, and then there'll be a follow-up video after you have had a chance to work on an example problem, which might be relevant to you. It's about picking an elective, maybe one might want to pick for the spring. And then I'll have a video follow up and kind of give you what I thought. So let me share my screen with you real quick. And we'll start the PowerPoint. So we're going to talk today about KT decision analysis. Now you might remember from before, after you do situation analysis, you could have a problem to solve, a decision to make, or a potential problem. So today, we are going to focus on, I think, the most exciting one, which is decision analysis. And that's one that as in engineering, we do a lot more of that than the others. So really what you want to do is how to choose the best solution from a number of alternatives. Now, one way to help you with this is try to write as concise a statement as possible of what you're trying to accomplish. You might remember there's an old saying attributed to Einstein that a problem well defined is a problem half solved. So it's the same idea here. Try to get as much information and get as concise a problem statement as possible. And to help you do that, you should obviously collect and analyze all the information and data associated with the project. It's always good to talk to people who also are involved in the project and get their insights on things. A lot of times people can give you intuition and insights that maybe aren't in the raw data. And if possible, always go and see the problem firsthand too. So just like I mentioned before, with talking to people that are familiar with it, you'll find that you get additional information, almost like a detective coming into a crime scene. They look, they see things, they get a feeling, they get information that's hard to quantify sometimes. And then, of course, confirm all this information, make sure it's valid. So you want to specify the objectives that you want to make a decision on. And usually these objectives are in two categories. There are things that you must have. So we'll just call those musts, kind of odd word to say. But these are things that your decision or requirements that you have in your decision. So if you're going to look at alternatives, alternative designs, alternative products, there are certain things that your solution must have. The second thing, a little more objective or subjective, I should say, are wants. These are things you want to have. And depending on how you rank those, you could have things that you want that are higher order or higher priority than things that you don't want. So musts, you have to have, very objective, and then more subjectively, wants. So musts really are mandatory to your solution. So if your solution has all those musts, then it's a go. And if it doesn't, even one, it could have 100 different things, but if your solution to that problem has only 99 of them, then it's going to be a no-go. You have to stop. So it's kind of thumbs up or thumbs down. Now, our wants are desirable, but they're not required. They're not mandatory. So when you go to do wants, one strategy in this particular analysis, decision analysis, is we're going to assign a weight to each want. And the higher the number between, say, 1 and 10, the more valuable you think that want or that desirable feature is. And then you're going to go and rate each solution, probably on a scale of 1 to 10, about how well that solution satisfies the particular want. And then all we're going to do is take the rating score, 1 to 10, 0 being it doesn't satisfy that want, 10 being it's the perfect solution for that want. Multiply the rating for each one times the weight. Again, the weight is where you, as the individual doing the decision, prioritize things that you want more than others. And of course, when you do that, you'll get a numerical score. And a high score wins, kind of basketball scoring. So again, assigning a weight is a subjective thing. You want to compare two wants together with their weights. If something is twice as important, make sure the weight is twice as important. And also, you need to have your weights be consistent. If you want a certain solution to come out, you can always rig the analysis. You can make certain things highly valuable, or certain wants that this particular solution has, make those highly rated and give them highly weighted, and then give them a high weight. And you can force the solution you want to be the best one. But it's always best to have a narrative, a rationale for how you're making these choices, especially going to your superior or your boss and you want to try to defend your solution. You want to have as much information to justify and validate your approach. So as an example of this, we're going to choose a spray gun for our manufacturing system. So we're making automobile parts and we need to paint them before they leave the factory. And we want to choose a spray gun. And we have 3 available spray guns, PaintRite, NewSpray, and Gun-Ho. Okay, we have 2 musts that we have to have. One, we have to be able to control the flow rate in the paint. So whatever spray gun we need would have some kind of adjustment, some kind of valve, some kind of setting. We control the flow rate. And of course, when it's all done, we have to have acceptable appearance. It has to work well for us. Now, some things that I'd like to have, these would be the wants, would be I'd like my system to be easy to service. Of course, everybody wants low cost and long-term use. That would be durability. And of course, if I've already got people in my factory or in my system that know how to use this particular gun, then that less training time and less startup time. Learning curve is lower. So these are all things that I want to happen. So here's my decision analysis. You can see at the top, I've got my must, adequate flow control, acceptable appearance, and there's the 3 guns. So we're going to do that first. So after some investigation, I found that PaintRite was a go-go, which means it has flow control and it has acceptable appearance. Did some spray out tests with NewSpray, and again, go-go. Now, I really like the Gun-Ho system. That's a personal opinion of mine. I know the guy who runs the company. He's always been provided us with great equipment. So this is their new system. I really like it. But when we checked it out, it did not have adequate flow control. So it's a no-go. So even though personally I'm invested some way in the Gun-Ho, or relationship with the person that makes it, and I've had good experience with in the past, this particular product does not work for us. So it's a no-go. So it's out of the running. So now I'm down to PaintRite and NewSpray. So how do I manage that? Well, you might remember I had my 4 wants over here that I was interested in. And now, in working with my engineers and people on the floor, I've ranked them, or provided weights in this way. So easy service, I said, was 7. So 1 to 10, that's pretty highly rated. Durability is important, but just not quite as much as serviceability. So I made it a little bit lower, only 6%, only 6 weight. Low cost was not as important to me. You can see it's almost half of service. So I'm willing now to accept easy service over price entry point, almost 2 to 1. And then with experience, I thought it was about the same. So this is my rationale, and I have to defend this to my superiors or my bosses or to other people in the group. I'm saying that low cost and experience are about the same, nearly the middle, about 4. And then these 2 are a little bit more weighted, with easy service being the most important. Now I take each of the systems and I rate them 1 to 10 and how they satisfy this. So my rating for the PaintRite system was 2. So 2 means it's low, which means it is not easy to service. In fact, it's terrible. It's very hard to deal with, very complicated system. In terms of durability, it's very high. They last a long time. Low cost, it's a little more expensive system. So I thought that was a low rated position. Again, your numbers can be slightly different from this depending on how you interpret the data. And then with experience is almost a 10. So I have people, a lot of people, who work in our system, and they have experience with the PaintRight system. So now I simply just multiply these together. So you can see the weight times the rating for the first one is 14, next one 48, 12, and 36. So I add that up for a total of a score of 110. So right now my PaintRight has a 110 score, which is really right now it's just relative. So now we go to NewSpray. Remember, my weights are the same. I haven't changed my weights, but now I'm going to rate the system compared to PaintRight. So when I look at serviceability, it's super serviceable. I mean, they send people out for no cost. They replace parts. They'll get you up and going almost in no time. So compared to PaintRight, the NewSpray system is super, super serviceable. In terms of durability, it's not as durable. So I'm looking over here at my 8, and I say, well, it's not as durable. I say it's a little bit, almost 3/4 as durable. You can actually quantify that if you wanted. If one system, say, lasts 10 years, the other system lasts 5 years, and you can make sure the rating is double. For cost, it does have a low cost. In fact, I can really quantify this part too. I could say, 7 to 3. That means that, it's less than half the cost. In terms of experience, though, I have very few people. In this case, maybe 20% of my people have the experience with this system, whereas maybe 90% of some have. So I rated that pretty low. But now again, weight times rating. My score for NewSpray is 63 for serviceability, 36 for durability, 28 for cost, and 8 for experience. I add that up, I get 135. So if I've done this as fairly as I can, then it's easy to see that the NewSpray system is the best choice for my situation. Again, overcoming my bias where I really like the gun-ho system, and really overcoming some other biases that, in terms of my people having lots of experience and durability, the other items came out in favor of NewSpray. Now, some other things I want to tell you about before I quit with this is to let you know that there is some risk in your choice. You can explore each alternative, what are the risks involved. And you can do a probability, again, 1 to 10, of the consequence of your decision. So obviously, 10 would be a high probability of some risk of making that choice. And then the seriousness of that, it could be life or death. If a certain device would cause people to be in danger, that would be a very high serious score. And if your particular decision led to that, or the probability was high, then you'd have a high probability. So you could also add to your decision on a risk association. And don't forget the problems with all these subjective measurements. If you give higher weights and scores, you could really predetermine a solution. So try to avoid loading your wants up using unimportant information and any kind of faulty perception or biases. So also look at what's missing. Is there missing information? What if this happened? What if that happened? So again, a post review of your analysis is always a good idea. Okay, so I'll stop sharing my screen with you now. So probably what you want to do next is look at the decision analysis I want you to perform. It's a sample problem where you have, I think it's 6, maybe 7 different types of electives, and you have some requirements for your electives. Even in our civil program, there are some requirements. And you want to try to choose which is the best elective for you. Now, these are fictitious courses, they're not real courses, but you could obviously apply this to your course choice, especially elective choices, any semester. So it's just an example. My opinion will be different than yours. Now the go, no-go parts we should all agree on, but when it comes to weights and actual choices, my preferences will be a little bit different from you. So again, there's no right or wrong answer except on the requirements, the mandatory parts. So when it gets down to how many of our solutions are go-go and we need to decide, you might come up with a different choice of course that works for you than I do. So check that video out and get us practice on decision analysis. Oh, and one other point, this will be part of the problem solving quiz later this week and on the final exam, because I can give you a decision analysis. I can give everybody the same weights and ratings and just ask you, can you calculate scores? Can you tell me which decision is best? So understanding the matrix of how a decision analysis is laid out and organized, then just processing that information will be all I want you to do. Okay, so until next time, be safe and take care.